take advantage of the inverse properties. So take log of both sides, and then apply one of the laws of exponents that says that, one of the laws of logarithm that says that the exponent is equal to coefficient. And now I select the logarithm. So collect like terms together, and then I select logarithm, I select x and solve for x. That's what we're going to see today in section 6.5. So let's go to 6.5 homework, and then we have 6.5 and 6.6. 6.5 and 6.6 today. So let's start with number 1, solving exponential and logarithmic equations where the bases are not equal. So this time the bases are not equal. The other day the bases were equal, so we didn't have to take logarithm. So we start by isolating the left-hand side of the e. The base this time is e. Okay, and this is going to be the same as, first of all, 5e to the power of 5x is equal to 10 minus 2 is 8. So subtract 2 on both sides. Then divide both sides by 5. So we are going to isolate e. And so we have e to the power of 5x is equal to 8 over 5. At this point, there's no way we can make the right-hand side to be equal to the left-hand side. The bases are not equal. So we have to take the logarithm of both sides. So we say log of both sides. Log of e to the power of 5x is equal to log of 5 over 8. Actually, 8 over 5. All right, so now we now use the power of exponents. One of the laws of logarithm says that exponent is coefficient. So on the left-hand side, we have 5x multiplied by log e. And by the way, I can actually take natural log. So I will go ahead and take natural log because this is base e. So I will take natural log of both sides because it's base e. So this time I will change this to natural log because it is base e. So I'm taking natural log of both sides. So natural log of e to the power of 5x is equal to natural log of 8 over 5. Okay, and now I will, the same laws for ordinary logarithm, common logarithm, and natural logarithm. So we have exponent is coefficient 5x multiply natural log of e is equal to natural log of 8 over 5 in parentheses. Okay, we already know that natural log of e is 1. So this is 1. And so we are now left with 5x. Therefore, x is equal to natural log of 8 over 5. Most of the time, I'm totally answer in terms of in exact form. Anytime I'm told to leave my answer in exact form, exact, and then I leave my answer in terms of natural log. So I will leave my answer in terms of natural log. It's a real number, so it's going to be a real number. So that is number 1. Let's go to number 2. We're looking for situations. We're now in situations where the logarithm on both sides, does not have the same base, or the exponents do not have the same base. So the bases are not equal. So if the bases are not equal, then, okay, so in number 2, we have a 6 multiply natural log of 8x is equal to 12. Divide both sides by 6. Now I have natural log of 8x is equal to 12 over 6. Now we will do, I'm going to take, first of all, there's no way the bases are not equal. So I will do exponential function. So this is how I'm going to change this to take the base e. Change the base to base e. All right. Okay, e raised to power natural log of 8x will give me 8x. Because we already know that if I raise a number to power log of x, that number is x. The same thing goes with natural log. So I will now use the rewrite 8x is equal to e to power 12 over 6. 12 over 6 is 2. And I can now bring this side. So 8x is equal to e to power 2. Divide both sides by 8. And x is equal to e to power 2 over 8. I can leave my answer like this. Leave my answer like this. Or I can put it in my calculator if I'm told to simplify. If I'm told to simplify, I put that in my calculator. All right. Number 3. Number 3, the bases are not equal again. The bases are not equal. So I have 6 over 7 to power x is equal to 4. And so what I'm going to do is take a logarithm of both sides, because there's no way I can change this number to this base. It's an exponential function. And so what I'm going to do is take log of both sides. So I'll now say log of 6 over 7 to power x is equal to log of 4. And then exponent is coefficient. It's one of the laws of logarithm. And so I have x multiply log of 6 over 7 is equal to log 4. And then I can now divide both sides. Divide both sides by log 6 over 7. So I have log 4. So x is equal to log 4, all divided by log 6 over 7. All right, and then I can simplify. And by the way, the denominator can also be written as log 6 minus log 7. All of them are in base 10. So you get the calculator and simplify. So x will be equal to log 4. Log of 4 divided by, I can rewrite it as log 6 minus 7, but I can just say 6 over 7. I'll get my calculator. All right, and I have log 4. So I'm going to clear. So I'll just put in log 4. This is log here, log 4. The base is 10. That is why it was not signified. I'm going to have log 4 here. And then I can store it in x. Store in x. Then I will go ahead and find the denominator, log of 6 over 7. So I find log 6 divided by 7. 6 divided by 7, close parenthesis, hit enter, and this is what I have in the denominator. And then I can find the value. So 0.6 minus divided by 0.7. And what do I have? I have 0.6 divided by 0.07. Okay, so 0.6 divided by 0.07. And this is negative. It should be negative. So because this is negative, it's an extraneous solution. The argument is not allowed to be 0. The argument is not allowed to be 0.